Hello everyone. So this video is going to be how to apply ideal gas law, which is PV equal nRT, to calculate for volumes. And the next video is gonna be how you would apply ideal gas law, which is the same equation, which is pressure times volume is equal to number of mole times R constants multiplied by temperature to solve for the mass in grams. Okay. So let's go ahead and look at what the question is telling you about. So go ahead, and I'm going to go ahead and read the question. What volume of oxygen 2? So with that being the case, so let me be very specific in terms of what it is variable, what these variables mean, okay? So I'm going to write it out like P is equal to what? Pressure. The unit has to be in ATM. And V, the volume. And the unit has to be in liter. And N is the number of mole, which is, is number of grams divided by molar mass. And then R is always a constant, which is 0.0821, which is ideal gas law constant. This number will never change. And also, what T is the temperature. It has to be in Kelvin. So if you are given Celsius, then you will just go ahead and add 273 in order for you to get a Kelvin temperature. So what I'm doing right now is to go over the practice problem with you. So let's go ahead and tackle the problems. So in this problem, I'm just going to go ahead and write this down. H2O2, which is hydrogen peroxide, really decomposes into water and oxygen gas. So now you need to learn how to balance the chemical equations. So how many oxygen do you have on the left hand side? And how many number of oxygen do you have on the right hand side? Then remember, this is the plus side, so however the number of mole over here of oxygen you have, you need to add that one with the number of mole of oxygen in the water to be equal to the number of mole of the hydrogen and oxygen for the peroxide. I'll give you a seconds or minutes to think about how you balance chemical equations. Now I'm coming back with the right coefficient right here. So what if I put 2 there and 2 here? So let's double check if the equation is balanced. How many number of hydrogen do I have? 2 times 2 is equal to 4. 2 times 2 is equal to 4. Therefore, it is equal sign. Oxygen, how many? 2 plus 2 is equal to 4. 2 times 2 is equal to 4. So now this is how we do it. So you have, in order for you to get to the right equation, you must be able to balance the chemical equation first, and then you will apply the ideal gas law equation, which is PV equal nRT. But since we are looking for, so we're actually going to be solving for volume. So volume is equal to nRT divided by pressure. So these are your final formula. So you're going to have to substitute the values in order for you to solve for the volume at the end of the process. So now let's go ahead and look at what's given. So on the question, when you are reading the question, it will tell you that 25 grams, 28.5 grams of hydrogen peroxide, is H2O2 is given. So now you have to convert that into number of mole first. That's the first step you should be doing. But the question is, how do we calculate number of mole given the grams? Anyone here knows? Okay, so basically you're trying to use the data analysis process to get rid of the units. So if I were you, I would just go ahead and put this one mole here and divide by molar mass of H2O2. So if that's being the case, so let's go ahead and use your periodic table that you should have to look for the number of oxygen and hydrogen, and you then add them up. But the question is, do we use H2O2 or do we use H and O only? The question is, you use both because this is the molar mass of peroxide, which is 34.015 grams. So grams of that and mole of that. So when you cancel the unit out, you see how I cancel grams of grams out? The only thing I have left is the number of mole of hydrogen peroxide of the given one. So you're gonna have to use your calculator to figure out what the number of that is, which is 0.838. So you have the number of mole of that. So I'm just gonna go ahead and write that down. Step 1, cover the given into the number of mole. So step 2, you will use whatever the mole you have and use the mole ratio. So I'm going to go ahead and write that use mole ratio. Okay. So what are the mole ratio? The mole ratio is the number of the coefficients. So let me write it down. It's I'm going to write down coef because you should know that coef means coefficients. And since we are trying to convert the number of mole of this one, we're looking for this one. So we kind of discard. We don't worry about this one, the term. So it's about 2 to 1. So given them, I'm going to go ahead and write that down first of all to begin with. 0.838 mole of H2O2. This is a very important step that you must write this down just like I do. And then you will use the mole ratio here. We follow these steps. You try to get rid of the mole of this one. So this is the mole of given. That's why I'm writing that down here. This is the mole of given. The mole I'm looking for, since I'm looking for oxygen, that's why I'm putting mole of oxygen here. And in this process, this is the mole ratio. We're gonna go back and look at the balanced equations. So what are the coefficients of these two? Oxygen, 1. That's 2. So anyone still remember how to get that? And then I'm just gonna go ahead and write it out over here, cancel this one out, because the point of this data analysis of the table is for you to crisscross every single thing that is not important and that leave the last term, that's what you're looking for. So with that being the case, so I'm going to go ahead and write it down 0.108, and that is the mole of oxygen 2. Remember, in order for you to substitute for the last equations, okay, I'm going to go ahead and write down step 3 first. Once we get the mole, so right now, in order for us to calculate for number of volume, we know the mole, we know this, but let's look at what's given from the questions. So the question itself will tell us that, so I'm just gonna go ahead and write it down, it's like given information, given info. So you are given info about, the temperature, which is 15. So remember 15 Celsius, you add 273, and that should give you about 288, and that's your K. And then your pressure, which is 2 atm. So now you know this, and then you know for sure that the constant R is equal to 0.0821. Let me go ahead and double check to see if you guys can see those numbers. If not, you can always refer back to, yeah, you can. So step 1, 2, 3, and now this is the last step. I'm gonna go ahead and write it down. Substitute in the step 4. This is the new information. I'm just gonna write out this new info. So you're gonna go ahead and write out, and you will substitute this. So your volume is equal to number of mole, and number of mole right here, it must be mole of oxygen only. We're not talking about the number of mole of the given, because we already in the step 2 figure out how to convert the mole of the given to the mole of looking for by using the coefficients. So now go ahead and put in the number. I'm just gonna go ahead and write it down. Number n is this one, not that one, because that one is more of a given. It's not what we're looking for, obviously. Okay, put parentheses because it's multiplication. Okay, my temperature is about 288, and divided by my pressure is about 2. So my final volume should be, when you plug this in the calculator, you would go ahead and multiply those three for the top 3 terms, and then divide by 2, and that should give you about 4 liter, and that's what you're looking for. This is your final answer. Here, then you get the point.